dear industry leaders and the most distinguished guests. Good morning. I'm Chuck from Semiconductors. This year, the main theme of SEMICON Taiwan is empowering the AI era. Today, I would like to share with you how compound semiconductors empower the application in AI era. First of all, speaking of AI, what's the image pop up in your brain? What's the vivid life in the future? It's not easy, right? So I asked AI to plot the future. This picture is drawn by AI. So it looks like in the future, this is a fancy wall. The car even can drive on the leg. And it looks like the wall is manipulated. AI will manipulate the wall. We don't surprise because that is from the view of AI. Personally, I believe in the future, AI will make our life easier and more convenient. In the future, with AI, we won't be stuck in the traffic jam, and we can make our life longer with a lot of sensors in a wearable device. And with AI, in the future, we can communicate with our friends and exchange customized information anytime, anywhere. But is that easy? Of course not. Let's think about what kind of technologies we need to realize such kind of a fancy world. Okay. So firstly, definitely, we need a high-speed computing. Okay. With such kind of high-speed computing, then we can do a lot of program learning and execution. Furthermore, if we would like to make it powerful, then we need to feed it with more data. So through the massive IoT, we can collect a lot of data. But how to bridge from the AI data center and to the edge end? Then we have to communicate, okay, computing and the edge end. So far, we have two ways to make it: wire and the wireless communication. It's the existing solution now. Moving forward, once we increase the data rate, then we trigger different kind of bottleneck for each portion. Let me explain one-on-one. Okay, so let's start from computing. Broadcom, Dr. Joe, he just mentioned that in a data center, I believe we will have very high-speed GPU and CPU. However, interconnection, okay, that would be a very critical part. So how to address that kind of interconnection speed? Then we will talk about that later. The second one, once we increase the data rate, that means that we either increase the linearity or we pull up the frequency. No matter how, then we trigger another challenge. Okay, the last one, but not least one, sensor. Currently, we put a lot of sensors, okay, in our daily life, but it also consumes a lot of power. So with the very limited power line, how could we make it to be used longer? So high efficiency and high integration, how to make it smaller, then we can put more sensors in the small gadget would be another issue. So all of them are currently a bottleneck. So today we are getting here to join the SEMICON. We try to think the best solution. What's the best semiconductor that can solve those problems? Okay. Now let's take a further look about the bottleneck and how to solve it. The first one had computing. Okay. With the high data rate, then we can see currently in a traditional data center or the new AI data center, we use couple line to link the servers. You can see once we increase the data rate, then that means that the transmit, the distance will be shorter. So how could we to address such kind of difficulty? Then fiber optics. So that's why Dr. Cho, he just mentioned about CPO, LPO, LRO, that kind of a solution earlier. But no matter how, we need a light emitting source to fulfill such kind of optical solution. The second one, communication. If we would like to increase the data rate, then how can we do it? We can expand the bandwidth. That means that we need to increase the operation frequency. But if we would like to increase it, then with the limited bandwidth, then we have to have a complex modulation, okay, either or. So let me summarize the evolution of our cellular phone from 3G, 4G to 5G. Okay, we can see the frequency from 2 GHz in 3G up to millimeter wave in 5G. Modulation-wise, QPS scale 16 quad in 3G up to 256 quad in 5G. So we can bet in the future for 6G, even though we don't know the spec yet, but we can estimate for frequency that will be go higher. So some people they estimate so-called sub-terahertz will be adopted. And we also foresee the modulation would be more complex. Okay. The third one, big data. Currently, we use a lot of sensors in our daily life, and in the future, we will expect the skin test sensor in earphone, and some people look for so-called glucose sensor or heartbeating sensor, even the blood pressure sensor. That kind of sensor in smartphone, smartwatch, and we will have advanced eye tracking sensor in AR, VR, that kind of device. However, think about that. With a lot of sensors, how could we to extend the battery life? Okay, especially for the wearable device. And if you in the future you would like to put more sensor inside, that means that you need a small form factor, the kind of solution. So high efficiency and the high integration would be the challenge or the bottleneck in the future. So all in all, no matter high-speed computing or the communication over big data collection, we have to think about the way to address such kind of issues. From my viewpoint, I do believe compound semiconductor is still the suitable solution. Why? Because compound semiconductor has its own special features. Comparing to silicon, compound semiconductor demonstrates high electron velocity. So it's 6 times faster than silicon. So it could be used for satellite communication, for cellular communication, etc. And with such kind of performance, it can also demonstrate low noise and high efficiency as well. Another, silicon is so powerful, so silicon can be used for almost all kinds of chip. However, don't forget, silicon cannot emit the light. Since for the Rayban gap, so compound semiconductor, it can emit light. So with the high speed and the light emitting such kind of features, semiconductor can be used for AI, the kind of challenges. In the past years, I shared with you a lot about the compound semiconductor solution for RF in SEMICON Taiwan. This year, I would like to draw your attention to optical solutions. From WinSemi, our viewpoint, it's not easy to realize optical device, especially active device. So today I would like to summarize some challenges we observe. Okay, so I divided to 2 parts. The first one is process, and the second one is integration. Okay. So let me share with you about our observation about challenges. Okay, during the process. It's quite common if you try to develop some active device just like edge emitting laser or visual device. Let's just start from the edge emitting laser. Okay, edge emitting laser, you need to rigorous the IP. Okay, but it's very easy for you to have some defect during all the process. Such kind of defect would misalign the light path, so that will cause some performance degradation. And the second one is for such kind of edge type of device during the caliber process, because the pressure is very easy to make the sidewall discontinued. Such kind of discontinued would emit the light, so would degrade the light performance. The third one, currently, many engineers would like to put a grating on top of a visual to improve its performance. So once we finish the etching process and to do the preservation, it's very difficult to get rid of void. The last one, people would like to have so-called multi-layer visual to increase the power. Even they try to beat edge emitting laser. So the difficulty is during the oxidation process, okay, because the layer, okay, if you would like to have a very uniform optical aperture, it's very difficult because the rate of oxidation is for the different layer is different. So all in all, they are all challenges and no matter how, we have to overcome, and we need to think a way to address that. With Semi, in the past years, we devote ourselves to create some technologies, and we try to solve such kind of challenges. Okay, so currently we have some achievement. Okay, let me share with you. Let me start from AP growth and regrowth. Okay. So you can see that with the very, if we have good regrowth, then that means that we can see that very clear each there. Then there is no any vague. And for different kind of device, the line, the light, the alignment is good. That means that we can have good light transition. And for rich type of device, no matter it's active laser or it's a passive the waveguide, after the kind of solve process, we still can keep very smooth sidewall to make sure we can have a good light performance. For visual grating process, even after the preservation, you can see we can have a so-called veer, a free, the kind of performance. Okay, the final one. Okay, now we can align all the optical aperture. Okay, and to make them very similar. So that means that in the future, even 8 junction or even 10 junctions, the kind of high power visual can be realized for autonomous LiDAR application. Integration, okay. For integration, it's also very important technology, and I think it's very critical trend. Just like I mentioned earlier, we do need technology to make the sensor to be smaller and to make it efficient. It's not easy, okay, but no matter how, we need to think a way to realize. So let me start from 6-inch VCSEL. Currently, VCSEL is mature for the single device, but the size is still not small enough. Why? Because we need a wire bond. Okay. If we use the wire bond, then we cannot reduce the size. And don't forget, if we have to form so-called the optical path, then we need the lens. Okay. No matter we use the plastic or we use the glass lens, then we cannot reduce the depth. With Semi, recently we announced the technology. We integrated microbump and micro lens together to integrate all the solution together. Then we can reduce the size. Okay, so with the in-house the microbump, then we can remove the wire bump. And if we can to realize so-called micro lens, then we can make the device smaller. Okay, we can dramatically to reduce the thickness. And we also can combine. Earlier I mentioned void-free grating and the multi-layer VCSEL. Then all in all, then such kind of technology can be used no matter for 3D sensing, for in-cabin LiDAR, or for in the future for smart city. This is for visual. On the other hand, you may be curious, how about indium phosphide edge emitting laser? Yes, okay. For if we integrate indium phosphide device, both of active and passive device, we integrate together to form a so-called photonic IC. This is an example. Then such kind of device can be used for telecom communication. But think about it, how could we to make it? It's not difficult because, again, interconnection. Okay, so with the different kind of device, we can have a butter joint, the kind of reverse capability in-house. And thanks to more than 20 years development, we have a mature air bridge technology for PN. Now we can use such kind of technology for photo IC. And we also develop multi-mode coupler. Then we can bridge different kind of device together. Even we have deep waveguide, we still can keep the sidewall very smooth. So if we integrate all technology, then we can to realize the photonic IC. Okay, so this is for edge emitting laser. Up to now, I already introduced all the challenges and the technologies. Then let me draw your attention to the business portion. So this page just show you how the market to be boosted by AI. So thanks to AI, compound semiconductor, the CAGR in the next 5 years, then we will have a strong growth. For our portion, we will have 6% CAGR, and for optical, even we can have double digit up to 12%. Then those devices will be used for a wearable device, just like an earphone, just like a smartwatch, smartphone. And even we can have the kind of device for in-cabin LiDAR or out of the car. For AI data center, then we can use optical communication to replace copper line. All in all, we can form so-called smart city. So let me conclude today my speaking. We start from the AI. In the AI world, we will have an easier and more convenient life. To make it, we need a high-speed computing, we need high-speed communication, and we need big data to make it. However, that triggers some bottleneck. That trigger the bottleneck for interconnection, that trigger the bottleneck for the linearity and the high frequency operation. And it also trigger the demand of high efficiency and high integration sensor. So compound semiconductor, it looks like it's still the best solution to address those challenges. As a worldwide #1 compound foundry, with semiconductor in the past years, we developed several technologies. I just show you. So we can have very smooth sidewall of rich type device, and we have a different kind of interconnection process. Then we can to integrate all the device together. In the future, I believe through the cooperation with all of you, then we can make the AI world to be real. Thank you.
Okay, now we have time for a couple of questions. Yes, please.
I think going forward in this AI era, indeed the optical communication is one of the key. So comparing or competing with silicon photonics, the common semiconductor and silicon photonics should have some harmonized process in the future. So what do you think how to harmonize that?
Thank you, Barry. This year, silicon photonics is a hot topic, and WinSemi will also join the alliance. So this year, we have a lot of topics to talk about that. I think to hit the point, I do believe heterogeneous integration will be the key for compound and silicon photonics. Why? Because it's still quite difficult to have a good, I would say, low loss that kind of transition. Okay, so from the light source to the silicon photonics. So I believe in the next years, a lot of researchers and a lot of engineers, they will put their resource, they try to improve the efficiency. Okay, and even from the industry side, I believe many companies will try to improve the yield because the kind of combination yield is still low. But conclude your question, I do believe the interconnection between compound and silicon photonics would be the heterogeneous integration. Thank you.
Are there any questions? Yeah, I do have one. For the CPO, you might require higher power laser up to like 200 milliwatts. So how do we prepare that though with Win Semiconductor?
Thank you, Dr. Wu. Yeah, that's a challenge for sure. Okay, for high power laser for CPO. We found that okay, from WinSemi, our viewpoint that just like I mentioned, that to have a good process is also very important because currently for high power device, just like even the DFB laser, we need to have a very high quality gross and regross AP, that kind of performance. So I think if it's not the turnkey solution within one fab, I think it's quite difficult to control the quality. Even for WinSemi as an example, even we do all the process in-house, it's still a challenge to us. We still spend a lot of engineering resource. So to answer your question, I think high power emitting laser, I think is a good direction for I would say CPO, and it's also a good opportunity, I think, for SEMICON Taiwan, or especially Taiwan, to think about the way how could we to build that kind of entry barrier. But it's not easy. We have to step by step. Thank you, Dr.